Yes, welcome back. So far we have seen the entity declaration and architecture representations for the VHDL programming. Okay, so in architecture case, three different models we have seen. Those are data flow model, structural model, behavioral model. And fourth one is mixed style, usually called, that is it includes more than one model. That is referred as the mixed model. Okay. Now coming to the point is timing and delays in the modeling. So how to introduce a delay in the programming part. Okay. So that is with the help of after clause or wait statement, you can include the delays in the programming. Okay. So here the slide showing how the after clause is used. Okay. So here one example statement is there, out to less than equal not in 1 after 20 nanoseconds. That is without this after class, what will happen? So immediately the result is assigned to the object out. Okay, out2 is the name of the object type signal. The value of in1 is complemented and assigned to the out2. But when you use the after clause, what will happen? The assignment will be done after 20 nanoseconds time. Okay, but it is not immediate, it takes certain time. Okay, so like that the delays will be added in the program. Similarly, there is a wait statement that is also you can use for providing the delay. Okay, and the next one is test bench. Okay, the test bench formation in VHDL. So what is test bench and what for it is means a test bench is also a VHDL program. Test bench also a VHDL program which is used to verify the results of a VHDL program developed for digital circuits. Okay, so whether that programming is correctly giving the results or not. Suppose if you take half adder, there two inputs we have and two outputs. Under two inputs, four combinations are there. With reference to four combinations, are you getting the correct results or not? Okay, so for that verification, the test bench is used. It automatically gives the inputs and also shows the result with reference to those inputs. Okay, but here we are going to see how to write the test bench. What are the different parts in it? Okay, that thing now we are going to observe. The test bench includes entity and architecture declarations again. So I said in test bench also a VHDL program. Okay, so that it includes entity and architecture declarations, input or output port declarations, instantiation of the unit under test, providing inputs to the unit under test, and finally displaying the test results. So these are the various parts you can identify in the test bench program. Okay, test bench program also a VHDL program which is used to verify the results of a developed program. Okay, so first of all, how to code the entity declaration and architecture declarations. Okay, so in order to know test bench, here is one example program named as first system. Okay, so of course before the entity declaration and architecture body, you have two statements here. One is library IEEE and another one is use IEEE dot standard logic 1164.all. Okay, so IEEE is the standard library which is used in almost all the VHDL programs as a first statement, and from that library we are using one package with the name standard logic 1164.all. Okay, so this is the package we are using from that library. What for is from because this is a package consisting the various operators and various data types whichever we are using in the programming. Suppose standard logic, this is the data type. This is a data type, right? Predefined data type. But where it is available? It is available in the package standard logic 1164. Okay. So in order to accept these data types, first of all you need to open that package. Okay. So from the library IEEE, the package which we are using is standard logic 1164. Okay. Dot all means all the declarations whatever this package has, they are in effective. Okay, so you can access anyone from that one. Okay, then entity declaration. So based on the entity declaration we can understand that this first system has two inputs, in one, into, and two outputs, out 1 and out 2. Okay, then if you observe the architectural model, it is in the mixed model. Here the programming style is in mixed, because here instantiation statements are there, signal assignment statements are there. So more than one style of structure you can observe here. So that's why, so both data flow style and structural style it includes. Then therefore it is referred as a mixed style. Okay, mixed style. So two inputs, two outputs are having some logic is happen in the system. But how can you verify the results for this one? How can you give the inputs to the system? Through the test bench, that we can see now. Okay. So what type of design sheet we are using? Vivado design sheet. Okay, Vivado design sheet is used for the simulation purpose. Okay. So here the test bench is in the same design suit. The test bench is connected in order to verify the results. Okay. Now first of all, entity and architecture declarations. So following library and opening the package, then an empty entity declaration. First of all, you can see in the test benches case an empty entity declaration, because there is no external and external boards here. So that one empty entity declaration with the same name almost you need to use. This is the test bench for the first system. That's why that is user defined name it is. Okay. So first system TB, for our understanding purpose, this is the test bench. Then coming to architecture body, in the architecture body also same syntax almost. The syntax is architecture name of first system TB is, that is the entity name. Okay. So the different declarations, the different input output port declarations usually. Okay. So all the inputs and outputs are declared with the help of a signal, with the help of a signal declaration, with the help of signal declaration. And also the entity, the main program entity can be declared as a component. Okay, can be declared as a component like this: component first system, port, in one, into, out one, out two, like that. Okay, so all the signals which are there in the entity declaration part of the main program, they are declared as a component in the test bench, and also they are all declared using the signal declaration. Okay, then begin. After begin, first of all the instantiation statement. The instantiation statement is you know already the syntax. First of all, a label name you have to use, that is UUT colon, component name is first system, port map of in one is connected to in1T, in2 is connected to in2T, out1 is connected to out1T. Okay, so the inputs which are applied, okay, they are connected to which object, like that. Okay, this type of connection is referred as named association. In previously while explaining the structural model, I have shown the instantiation association list as positional association. Positional association. They are just representing all are with separating by comma. Okay, here. So which object is connected to which object? Like that. Here the data values are. I mean data objects are connected or represented. Then after that, providing inputs to the unit under test. How the inputs are applied. That is, with the help of a process statement, the inputs are connected. Now see the process statement. So process begin. Wait for 100 nanoseconds. That is, it is used to provide the delay of 100 nanoseconds. Then apply the values. So in1 t is 0, into t is 0, 0. So the first values which we are assigning are 0, 0 for the inputs. Okay, then from this object they are connected to the in1 and into in the main program. Okay, similarly after 100 nanoseconds again another set of inputs we are applying, that is 0, 1. Similarly for every 100 nanoseconds delay we are giving all the 4 combinations. 2 input now, it has 2 inputs main program. So 4 possibilities are there, 0, 0, 0, 1, 1, 0, 1. After that one more wait, then end process. So now this process statement, what for this process statement? To apply the inputs or to provide the inputs to the unit under test. Okay, so end data flow. So after that it closes the program. So this is the test bench. So by providing these values, finally it shows the results. It shows the results in the timing diagram nature. The timing diagram, you know the timing diagram in case of counters and registers case, you observe that the timing diagram on and off states you can observe. So with reference to 4 input combinations, what is the expected sum and results that you can observe in the form of timing diagram. Okay, in the form of timing diagram. Okay. So like that a test bench will be prepared for each and every program in order to verify whether the developed program is properly functioning or not. Okay. Like that you prepare certain test benches. So when you have a chance to applying, verifying the results with the help of tool, it is helpful, right? Okay, thank you.